All right, guys, we left off with example 4, which is a really nice place to stop. So examples 1, 2, and 3, the first page of this section notes we learned about finding the nth term of an arithmetic sequence, both explicitly, recursively, a little bit of a challenge problem with number 3, where we were given two terms, but not the first term. We had to find the common difference from that. We also used the common difference to find the first term, to then find the explicit formula, to then find the thousandth term. Okay. We'll now transition into finding the sum of an arithmetic sequence, and before we get into formulas that we'll need, if it's as simple as adding up terms, feel free to just add up the terms. Find the sum of the first 8 terms. Okay. Common difference looks like it's 3, which means we have 16, 19, and we need one more. That's the first 8 terms. 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22. That will get you the sum of the first 8 terms. And that happens to be, let's do a little quick mental math, looks like 92. All right. So we got that going for us. All right. If it's easy, make it easy. Keep it easy on yourself, okay? But let's think of this question here. Top of the next page, or top of the next page. Suppose we were asked to find the sum of these 10 terms. How can we find this without adding each singular term together? Maybe this will lead into a formula. All right, well, let's look at this. We have 10 terms here, okay? And if you notice, what if we grouped terms together? Like, what if we grouped the first term and the last term that we see and added those together? That would be 47. What if we grouped the second term and the second to last term together and added those together? That would be 47. And the third term and the third to last term, that would be 47. All right, and the fourth term and the fourth to last term, 47. And these two, and that would be 47. Interesting. If we added up those 5 47s, 5 of them, we should get the sum of this equation. Or sorry, the sequence. Okay, you can check your math with what we did here. Now, let's see what we really did here. Okay, what did we do? Well, we added the first and the last term. Okay, so A1 plus AN equaled 47. Okay, when we added all these other groups of 2, it also equaled 47. Okay, how many 47s? There were 5 of them. Why 5? Why were there 5 47s? Well, there were 10 terms, and we grouped each of those 10 terms in groups of 2. So how many groups were there? There were 5 groups. So n over 2 happened to be 5. Okay. So we added the first and the last term together, and we multiplied that by the number of terms divided by 2. 47 times 5 gave us the sum of that sequence. That was interesting. Okay, so we grouped them into 2, then took half the amount of terms and multiplied. All right, cool. All right, we'll give you a definition, and maybe we'll see some similarities of what we did there. For the arithmetic sequence, a sub n equals the first term plus the difference times n minus 1, the nth partial sum. Remember, when we're dealing with partial sums, we're going to be looking for the first however many, the sum of the first however many terms. Okay? Couple different formulas we can use. Two different formulas we can use. Which one of those is kind of representative of what we did? Which one of those is representative of what we did up here where we grouped them into 2? I would say it's this one. Dividing the first term plus the nth term divided by 2 and then multiplying by n, wouldn't that be the same as adding the first term and the nth term and then multiplying by half of n? Yes, it would be the same. Okay, so 2 different formulas that you can use. All right? Two different formulas that you could use. So, n over 2 times the first term plus the common difference times n minus 1. Or the one that's probably more popularly used right here. Find the sum of the first 40 terms of the arithmetic sequence if we do assess on this. These, the sum of the nth term of an arithmetic sequence and the sum of an nth term of a geometric sequence, those will be given to you. Okay, you do not have to memorize this. Find the sum of the first 40 terms of the arithmetic sequence, 3, 7, 11, 15. If we can find the first term, if we can find the last term, that's good. Or, if we can find the first term and the common difference, and how many terms we're going to use, we can do that as well. I don't have the last term here. If I want to find the last term, I could do that. All right, but why don't we just use the formula that doesn't require us to find the 40th term? This one right here. So, we're going to find the sum of the first 40 terms. 40 over 2 times the first term, which is 3, plus 40 minus 1. 40 is the n value, times the common difference. The common difference would be 4. If we do that very simple math, we would get 3,240. All right. If we wanted to use this other formula, the only thing we'd have to do is we'd have to find the 40th term. Okay? So, the nth term is the first term plus the common difference times n minus 1. If I want to find the 40th term, 3 plus 4 times 40 minus 1, and the 40th term happens to be 162. 40 minus 1, 39, 162. Is that right? No, 159. All right. The 40th term is 159. Now we can use this formula. The sum of the 40th term is 40 over 2 times the first term plus the last term. Okay, this came from what we did up top, where we grouped these into 2. That's why this works. We had 20 groups of 162s. And again, we would get 3,240 as the sum of the first 40 terms of this sequence. All right. Find the sum of the first 50 odd natural numbers. First 50 odd natural numbers. Remember natural numbers from our previous notes? Those are the counting numbers beginning with 1. So we got 1, 3, 5, 7, ... all the way to the 50th. Okay? Again, we can use this formula. I would suggest using this one because we don't have the last term. So, the sum of the first 50 is 50 over 2 times the first term, which is 1, plus 50 minus 1 times the common difference. The common difference happens to be 2. Okay, and we would get 2,500. Now, if you were a little bit ahead of the game, and the first 50 odd natural numbers, well, the last of those should be 99, if there's 50 odd and 50 even numbers from 1 through 100. That makes a lot of sense. If you were to know that, then we would want to do the sum of the 50th. We could say, all right, 50 over 2 times 1 plus 99. Really, we have 25 groups of 100. There you go. And we're off to the next side of our notes. Now we get into some things that actually could be useful here. Okay, kind of a couple cool problems. Example 7, you can read your construction company was hired to build a new concert venue. The management team at the venue told your company they want to have at least 3,600 seats. You head out to the construction site. You take a look at the land, you survey the size, you say, okay, based on our calculations, you can have 42 rows of seats. The first row could fit 30, and each row back from that would be able to fit 2 more seats than the previous row. Can your company meet the demand of 3,600 seats? Okay. Well, if we think of this as an arithmetic sequence, the first term would be 30. The common difference would be 2. 2 more seats than the following one. The n value is 42. And we want the sum of the first 42 terms here. Okay? So we have 30. So 42 over 2 times 2 times the first term, which is 30. It's coming straight off of our notes here, straight off of this formula, plus 42 minus 1 times the common difference. Okay? All right, so 21 times 60 plus 41 times 2. So we got 21 times, this is 82 plus 60 is 142. And 21 times 142 is 2,982 seats. So you would come back to, so no would be our answer. We cannot accommodate that. Right? Not from what our construction company sees with how much land is to be built. Okay? We have a little extension question that I'd like you to try to take care of. And example 8 I would like you to try to do as well. Okay? So take a look at the extension question. Take a look at example 8. How many terms must be added to get to 572? Okay, we're kind of using a similar formula, but in reverse. All right, what else do we got here? I think that should be it for the section 12.2 notes. After you're done with the extension question and example 8, you can check back on the Schoology folder. In today's folder, I will have the hard copy version of these notes posted. You can check your work for the extension, and you can check your work for example 8. You bring any questions you have to me during office hours, or maybe you just see that you got it right, or you can kind of pick out your mistake from the work that you'll see on that hard copy. Okay. So most importantly from this set of notes is understanding what an arithmetic sequence is, how to write the nth term of an arithmetic sequence, the explicit formula where we have the first term plus the common difference times n minus 1, and then how to work with the formulas for the sums of an arithmetic sequence, which would always be given to you if we were to assess, okay, both of these formulas.